For decades, humanity has gazed at the stars, imagining we understood the universe's vastness, thinking we were slowly piecing together its story. We believed each new telescope brought us closer to the full picture, that each discovery filled in another missing chapter of cosmic history. But everything changed with the James Webb Space Telescope. Its first colossal datasets didn't just add details, they shattered our expectations. In a single breathtaking image, stretching back 13.5 billion years, Webb revealed a universe far more populated, complex, and advanced in its infancy than we had ever imagined. We thought we knew the scale of everything, but this new vision forces us to confront the staggering truth. Our cosmic perspective was profoundly incomplete. What we are about to see doesn't merely expand the map of the universe, it redefines our place within it. Before the James Webb Space Telescope, our deepest look into the universe came from the Hubble Ultra Deep Field, captured in 2004. Pointing at a seemingly empty patch of sky for over 11 days, Hubble revealed roughly 10,000 galaxies, each containing billions of stars, offering humanity its first true glimpse of the cosmos at great distances. This image became the benchmark for our understanding of cosmic scale, helping astronomers estimate that the observable universe contained around 2 trillion galaxies. Yet even this remarkable achievement had limitations. Hubble relied primarily on visible and ultraviolet light, which meant the earliest galaxies, whose light had stretched into the infrared over billions of years, remained largely hidden. For decades, our vision of the universe's infancy was incomplete. Obscured by cosmic dust and the vast distance of time, we could see glimpses, but the full story of galaxy formation, structure, and evolution remained out of reach, waiting for a telescope capable of peering further back and revealing what had always been just beyond our grasp. The James Webb Space Telescope changed everything. Equipped with a giant golden mirror and finely tuned infrared sensors, it was designed to see the universe as it had never been seen before, through cosmic dust, across billions of light years, and deep into the earliest epochs of time. Its first major mission, the Cosmos Web program, dedicated over 250 hours to scanning a patch of sky roughly 3 times the size of the full moon, capturing thousands of separate exposures and stitching them together into a single seamless image. The result was staggering, a contiguous map containing over 780,000 distinct galaxies, stretching back 13.5 billion years. For the first time, astronomers could study the full evolution of the universe in one frame, from its infancy just a few 100 million years after the Big Bang, to the mature galaxies we see closer to home. This wasn't just a more detailed view, it was a complete recontextualization of cosmic history, showing not only the individual galaxies, but the vast cosmic web of clusters, filaments, and voids that define the universe itself. The scale was beyond comprehension, and the discoveries it contained would challenge decades of scientific assumptions. Peering into the era known as Cosmic Noon, roughly 10 billion years ago, the James Webb Space Telescope revealed galaxies in their most prolific phase of star formation. These were energetic, blazing with the light of young hot stars, caught in gravitational dances that shaped their growth. Yet even here, Webb uncovered surprises that defied expectations. Some galaxies had already stopped forming stars, quenched long before scientists predicted, while others displayed remarkably well-structured spiral arms at an age when such organization should have been impossible. Among these discoveries was the extraordinary Infinity Galaxy, 2 colliding galaxies forming a figure 8 with a supermassive black hole emerging not in the center of either galaxy, but suspended between them. These fleeting, rare events could only be captured because of the telescope's unprecedented ability to survey such a vast volume of space. Each anomaly, Each unexpected formation forced astronomers to reconsider the pace and mechanics of galactic evolution, revealing a universe far more dynamic and surprising than our models had ever suggested. Pushing even further back in time, James Webb's gaze reached the cosmic dawn, just a few 100 million years after the Big Bang. Here, the revelations were nothing short of paradigm-shattering. Previous models predicted only a handful of faint, primitive galaxies existing at this early epoch. But Webb found a remarkable abundance of bright, fully formed systems. Some of these early galaxies, like GDZ14O and MOMZ14, existed merely 280 to 290 million years after the universe began, already luminous and containing heavier elements such as carbon and nitrogen. This indicated that at least one generation of stars had already been born, lived and died, enriching the cosmos far earlier than theorists had ever imagined. The timeline was almost impossibly fast, challenging the foundations of our understanding of cosmic evolution. The universe's first chapters, once thought sparse and gradual, now appeared filled with complexity, structure, and life-giving processes operating at speeds that defied our expectations. Each discovery rewrote the narrative of the early cosmos, forcing scientists back to the drawing board to explain how such advanced galaxies could form so quickly. The scale of the cosmos Webb map is staggering. A single patch of sky, tiny compared to the whole, contains over 780,000 galaxies, each representing billions of stars and untold cosmic histories. To put it in perspective, if Hubble's ultra-deep field were printed on a sheet of paper, the same resolution of Webb's map would stretch over 13 feet on each side, offering a panoramic view of the universe's structure and evolution. This isn't merely about counting more galaxies, it's about seeing the vast cosmic web in which they exist. Clusters, filaments, and immense voids define the architecture of the cosmos, and Webb allows astronomers to study these structures in unprecedented detail. The data reveals not only the individual galaxies, but how they interact, grow, and shape the universe itself. It redefines our perspective, transforming our understanding from isolated points of light to a sprawling, interconnected cosmic metropolis, a reality far richer and more intricate than we had ever imagined. The discoveries from James Webb don't just expand our view, they upend our understanding of cosmic history. Galaxies that theories predicted should be small and primitive are instead bright, massive, and surprisingly mature, even in the universe's earliest epochs. Supermassive black holes are forming in unexpected places, and the processes of star and galaxy formation appear to have occurred far faster than models suggested. Each new observation challenges assumptions about how the cosmos evolved, forcing scientists to reconsider timelines, mechanisms, and the fundamental physics behind structure formation. This isn't incremental knowledge, it's a paradigm shift. The universe, once imagined as gradually unfolding and sparsely populated in its youth, now appears dense, dynamic, and astonishingly advanced from the very beginning. With every pixel of data, Webb reveals a cosmos far stranger, more complex, and more astonishing than we ever dared hope to see. Even with this incredible map in hand, we are only beginning to grasp the true scale of the universe. The cosmos Webb field represents just a tiny fraction of the sky, yet it contains more galaxies than Hubble ever revealed in decades of observation. Each new discovery raises more questions than answers, pushing astronomers to rethink the pace and mechanisms of galactic evolution. We are witnessing a universe that is not only larger, but more organized and advanced at an early age than we ever imagined. A cosmos where stars, galaxies, and black holes evolved rapidly and sometimes unexpectedly. The implications extend beyond science. They challenge our place in the universe, forcing us to confront the sheer magnitude and complexity of the cosmos. And the most thrilling part, this is just the beginning. With Webb continuing to scan the skies, the next revelation could arrive at any moment, offering insights that might completely rewrite our understanding of how the universe came to be.